Here is an astronaut, out for a little spacewalk. At this distance, he looks pretty big. As we back away, we see more of his surroundings, but the astronaut himself looks smaller. At this distance, he looks tiny and lonely as he seems to float above the Earth. And at this distance, he's lost from view completely. One person doesn't seem very big compared to our giant planet. The true scale of our planet is hard to imagine. But what about trying to wrap our mind around the scale of the entire universe? Is it even possible? Let's get back to a scale we understand better. This student is studying tiny objects far too small to see directly with a microscope. Compared to the object she is studying, this girl is enormous. But one classroom can hold many students, and there are many classrooms in a modern school building, like Edison. To a bird flying high overhead, Edison looks like this. At this scale, you would be hard to see. Notice the two cars parked to the west of the building. As our virtual point of view moves higher, you can see the surrounding fields, cemetery, and some of the houses along Elm Street. More and more of this part of Wheaton comes into view as we move higher and higher. Now you can see the local golf course and the downtown Wheaton area to the north. Individual houses are getting hard to see. The neighboring towns, Winfield, Glen Ellen, and parts of Warrenville now come into view. Can you still spot Edison? The mile-wide ring of Fermilab and the Fox River are now visible to the west. Soon you will see Chicago to the east. The city of Chicago now appears. That blue area is the nearest part of Lake Michigan. We are still centered on Edison, but now other states begin to appear. Wisconsin to the north, Indiana, and a corner of Michigan across the lake. More of the upper Midwest now appears. The major highways are highlighted, otherwise they would be invisible at this height. In fact, our virtual viewpoint is now in space, roughly at the altitude the space shuttle flies at. All of the Great Lakes, as well as part of Canada and the Atlantic Ocean, are now within our expanding view. These Google Earth images are made from real images, but the real view would not show borders and would show many clouds. We finally are high enough to see our planet as a sphere. We are still centered on you, sitting in room 107, Edison Middle School, but now even Wheaton is too small to be seen. No matter how much we move back, you will never see the entire surface of the Earth. The eastern hemisphere is on the other side of the sphere, as seen from the direction we are traveling. As the Earth becomes a lonely-looking dot at the edge of our view, we get a glimpse of our nearest neighbor in space, the Moon. This is the farthest that humans have ever traveled away from our planet. It was a 3-day journey in a very fast rocket. Light can make the same trip in about 1 second. Light is the fastest thing in the universe. The bluish line represents the path of the Earth and Moon as they follow their year-long orbit around the Sun. As we continue to back away, you can see the orbital paths of all 4 inner planets, but at this scale, the planets and even the Sun are too small to be seen except as points of light. Light would take about 20 minutes to cross our field of view now. Beyond the inner planets and the thin ring of rocky material known as the asteroid belt, we see the orbital paths of the giant outer planets and Pluto. Only robotic space probes have ever traveled this far from Earth. We now see that Pluto is just one of many objects orbiting our Sun at this great distance, forming what is known as the Kuiper Belt. The outer edge of the Kuiper Belt blends into a sphere of millions of icy objects known as the Oort cloud. These frozen comets extend to the farthest edge of our solar system. Light would take many days to cross our view now. Expanding our scale much more quickly now, we finally see some of our Sun's neighboring stars. The nearest, Proxima Centauri, is so far away that light would take more than 4 years to reach it from the Earth. As we continue outward, hundreds and then thousands of stars come into view. Our own Sun, a fairly average star, is lost among them. Now, millions of stars, too faint to be seen individually, begin to take on structure of their own. Dark lanes of interstellar dust are now seen. Finally, the great spiral shape of our Milky Way galaxy is revealed. Our Sun is one star in the Orion spur of the Sagittarius arm of our galaxy. That bright central region is made up of more stars than you could count in your lifetime. It also contains a supermassive black hole with the mass of millions of suns. Our Sun orbits that black hole, just like the Earth orbits the Sun. Light, still the fastest thing in the universe, takes tens of thousands of years to cross our view now. Our galaxy, the Milky Way, is the second largest in a group of 30 or so galaxies that form a cluster known as the local group. The local group, in turn, is part of a group of thousands of galaxies known as the Virgo supercluster. As we see more of the universe, the galaxy clusters begin to take on an even larger structure. At this scale, points of light are not stars, but clusters of galaxies, each containing many billions of stars. The dark voids are so large that light takes millions of years to cross them. This structure extends farther than our most powerful telescopes can see, but it was generated in the first few moments of the universe, 13.7 billion years ago. At this scale, we are at the limits of human understanding, but not at the limits of the universe. The universe may extend so far and be expanding so fast that light from more distant parts will never reach us. Some theories suggest that other dimensions may be folded up inside the ones that we can perceive, and that other universes may exist side by side with our own. Still other theories suggest that we live in a multiverse with multiple universes extending to infinity. If the universe is infinite, then we are infinitely small in comparison. But we are still amazingly special and important. Because remember, it is the human mind that is trying to figure all of this out, and that is pretty amazing.